Okay, looking at today's do now, we're going to start with which equation represents the circumference of the circle below. So we know that circumference is equal to pi times d. As we look at it, that's definitely answer choice A. And we can see that answer choice B is really just, they've switched the order of the d times pi. Using commutative property, that's totally okay. As we go through, we also know that d is equal to 2 times the radius. So we can actually substitute that d in the equation. C is equal to pi times 2r. So all I've done is taken the 2r, which is equal to d, and replaced it with that in the equation. So C is equal to pi times 2 times r. And if I look at this, answer choice C and answer choice D are both combinations of multiplying 2 and pi and r, just in different orders. So those both work. None of the rest of these are equivalent. 2 times pi times d would not be the same, nor would pi times r. Those would be incorrect. All right, so remember we have two equations that we really can use. Generally we call them pi times d and 2r times pi, or pi times. Anyway, those are the two that we typically stick with, and those are our circumference equations. So we just use those two different equations for circumference, dependent on how many, whether we're given the diameter or the radius, which suddenly makes this particularly easy. Find the circumference of the circle below. C is equal to pi times d. My diameter here is measured across all the way is 42, pi times 42. And we're seeing that a couple of our answers are given in terms of pi. So this tells me that 42 times pi is equal to 42 pi. It's a lot like having an x in there. It's just saying, hey, I know you multiply by pi. I'm not really worried about you doing it. And finally, find the circumference of this circle. This circle is only given us the radius, so the radius is equal to 14, which means the diameter would be twice that, which would be 28. And so find the circumference of the circle. So circumference again is equal to pi times d, or we could say pi times, or circumference is equal to 2 times the radius times pi. We've already kind of done the 2 times the radius part. 2 times the radius here is 2 times 14 times pi. So gives me 28 pi, and we did that when we just figured out what the diameter was, so not incredibly necessary. We see that answer choice is D, and again, if we just went ahead and found the diameter on our own, that's 28 times pi as well. Same thing. Alright, we're going to expand our knowledge and practice a little bit of that today as we look at our aim. Alright, today's aim Kipsters will be able to solve problems involving partial circumferences. Kipsters will be able to solve problems involving partial circumferences. Alright, so here we have the arc to the right. It represents half of a circle. If the circle has a diameter of 12 centimeters, how long is this arc? So when we're looking at this arc, what we see here is that this is not a full circle. However, it is part of, if we thought about this, extending it out, this would be part of a full circle. In fact, it tells us it's a semicircle, so it represents half of a circle. So this is half of a circle. It tells us the diameter is 12 centimeters of what that full circle would be. So when we look at this, the value that we're looking for is the circumference would be equal to pi times 12, or the circumference would be equal to 12 pi. However, I want half of that. So I want half of the circumference is equal to half of 12 pi. Well, 1/2 times 12 would be 6. So the value that we're looking for is 6 times pi. And I'm just going to leave my solution in terms of pi for now. Remember, there are several different values that we can plug in for pi. We could use our calculator, use the pi button. Pi is approximately 3.14. Pi is also approximately equal to 22/7. So we can get to this point and then just use whatever value it tells us to plug in for pi. Here we have the arc represents 1/4 of a circle. So I want you to draw some conclusions. Go ahead and talk with your group. How do you think you're going to find the value of the length of this arc? So pause the video and have that. How do you think you can find the value for the length of this arc? All right, go ahead and let's test this hypothesis that you have. So I've drawn this out kind of as a circle whose diameter would be 12 centimeters. And so what we're looking for here is, as we think about this is really 1/4 of that circumference. So realistically, once again, we're looking for 1/4 of the circumference, and the circumference is equal to 1/4 of the diameter, pi times the diameter. So this would be 1/4 of 12 times pi, and 1/4 times 12 would give me 3 pi. So our expression that we can originally write as kind of our full expression with nothing plugged in would be here. Then we can simplify down after plugging in down to 3 pi. Alright, the next one says the arc to the right, and it looks like we've got some extra work over here. We'll deal with that in a second. Represents 1/3 of a circle. So here we're thinking about this. I could extend this out. That would be what my full circle looks like. And my diameter coming across here. Sorry, it says the radius would be 12. So my radius is 12 centimeters. And that means that I need to know my diameter, which would be 12 centimeters plus 12 centimeters, is D is equal to 24. So that's one thing that we really have to be careful of, making sure we know what to do when we're given the radius instead of the diameter. Here we can go ahead and say, alright, so this is 1/3 of the circle. So what do we think we need? We need 1/3 of the circumference. So 1/3 of pi times d. In this case, the d is now 24. 1/3 of 24 times pi. So that's 1/3 of 24. Doing that calculation is going to be 8 pi. Okay. So that's how we can find partial parts of a circumference. Is all we're really doing is we're multiplying the fractional part that we're talking about times the circumference. Very similar to finding percentages of a whole or parts of a whole for any other type of problem where we've done that concept. Alright. A circle is inscribed in a square as seen to the right. What is the circumference of the circle? Alright, so we're given a full circle here, so we know that when we're finding this one, we're going to be looking for the circumference of the full circle. It's going to be pi times diameter. So for this particular problem, we just need to figure out the diameter of the circle. And really, this is just an exercise in visualizing that this distance across here is going to be the same for the entire square. And so we know that our diameter is equal to 16. So here our answer is going to be equal to pi times 16, or 16 pi. All right. Find the perimeter of the semicircle. So now we're being asked to find the perimeter of the entire semicircle. So we've got this part here that I've just outlined in red. That's our circumference portion of this particular. And then we've got this straight line portion. So we already know the straight line portion. We're going to write a single expression to represent this though. So the arc part is half of the circle, half of the circumference. So I'm going to start my expression by saying this is going to be equal to 1/2 of the circumference plus the 17 from our kind of blue portion. This would be on our entire expression. So half of the circumference, so that's half of pi times d. So I've just taken my equation for circumference, which is equal to pi times d, and plug that in. And now I'm going to go ahead and plug in my diameter, which is measured as 17. Let's say that whole thing is 17. So now I've got all of the values here. It tells me to plug in 3.14 for pi, so I'm actually going to come back and replace this with 3.14. So now I need to do all this multiplication. You can use your calculator to do this. If you're going to do that, 1/2 we can plug in as 0.5, and times 3.14 plus 17. Thinking order of operations, we need to do this multiplication first. I do all of this multiplication using 3.14, get 26.69 plus 17. Now I can go ahead and add that together. That's going to give me 43.69 inches. Now notice there's no pi in this answer because we did plug in a value to represent pi. Alright, find the perimeter of the figure below. So a lot of times the first thing that we want to do when we're asked to find a perimeter is to outline the perimeter. So I'm outlining the perimeter, and kip yes or kip no really quickly. Is the 10 meters inside part of the perimeter? Okay, so the answer to that question is no, it's not part of the perimeter, it's on the inside. However, it is an important measure. What does it represent? Answer this within your group. What does it represent? What does the 10 meters represent in part of this problem? You and your group should have said to each other that this is the diameter of this semicircle. Alright, so looking at this, thinking about this, we have a half of a circle, so we need on the perimeter half of the circumference plus 6 meters and 6 meters. Alright, so I'm going to plug in my equation for circumference, 1/2 of pi times d. I'm going to go ahead and combine these like terms because I can. Now I'm going to plug in my value for d, which is 10. 1/2 of 10 times pi. And at this point it hasn't given me a value for pi to use, so I'm just going to leave it as pi. It's going to give me 5. 1/2 times 10 is 5 pi plus 12. And you know, if this is Khan Academy, or I don't give you what I want you to use for pi, I'm perfectly okay with you leaving the value like this. Now, if we wanted to from here, we could obviously plug in whatever we wanted, whether we wanted to do the 22/7 or the 3.14. 5 times 3.14 plus 12 would be 15.7 plus 12, which is 27.7 meters. Okay, so looking at this, we should see that now our conceptual pieces here, that we have find the value of whatever our arc portion is, and we can add that to any other straight line pieces around. And that's how we're going to find the perimeter of these shapes that have portions of circles in their circumference. All right, so let's flip on over to the other side. So we've got two problems here. I want to help you get started on this one, and then the other one, then you should be able to finish both of them on their own. It says Marjorie is designing a new set of placemats for her dining room table. She sketched the drawing on a piece of grid paper. The diagram represents the placement consisting of the rectangle and two semicircles on either end. So this is her placemat shape. It says each square on the grid measures 4 inches in length. First thing I want you to do is label all parts of the diagram in inches. So go ahead and label all parts of the diagram in inches, and then quickly check back in. So pause the video really quickly to label with your group. So as we look at this, we see that this is 3 squares wide, which is 3 times 4 inches. So this should be labeled as 12 inches. That means this is also 12 inches. And this height here is 2 times 4 inches. So that means this is 8 inches and 8 inches. So now with your group, just really quickly before you start writing an expression for this, go ahead and highlight or circle or sketch around the perimeter of this, because that's what we're actually looking for, because it tells us that Marjorie wants to pull gold trim around the perimeter of the placemat. So make sure that you've identified for yourself what the perimeter is, and then come back and write an expression. Alright, so when we're thinking about the perimeter, we should see that the perimeter goes all the way around. Looks like this. Now I want you to go ahead and write an expression. So think about what makes up this, and write with your group an expression that represents the perimeter of this entire piece. Okay, so with your group, you should already have this written out, an expression for you guys. You don't really need to have done the solving yet. Maybe you have, maybe you haven't. If you haven't already, go ahead and pause the video if you haven't already written that expression. Alright, so looking for this, what I see here is I see half of a semicircle. So this part in red is going to be 1/2 of a circumference. I have plus 12, and then another 1/2 of a circumference, plus 12. Now I could go ahead and start plugging in my circumference is pi times diameter here, but actually if we think about this expression and we go ahead and combine like terms, we find something very interesting but very logical happens. So if I just kind of make this 1/2 c, I'm just using commutative property, plus 1/2 c plus 12 plus 12. I can combine these like terms. 1/2 c plus 1/2 c would be just 1 whole c plus 24. And now when we think about that, that's going to make a lot of sense here. It's like we have 1/2 of a circle, and you have half of the circle. So when I start finding the perimeter here, really I've got a whole circle that I'm working with here. So I'm going to replace that with 1 times pi times d plus 24. Alright, so I've simplified this expression. Many of you may have gone the long way about doing this, but you would get the same answer. If you haven't already, go ahead and plug in 3.14 for pi, and go ahead and simplify to find an answer, 3.14 as pi. Alright, so I've plugged in 3.14 and 8, or 3.14 for pi, and looking back up in my sketch and my diagram, each of those semicircles is 8 meters. And so I've plugged in 3.14 and 8 for my pi and my diameter, and I've simplified this out to 49.12. Now if we go back and we went all the way back, I'm going to just plug in 1/2 times pi times d plus 12 plus 1/2 pi times d. So basically I've gone back to this original expression that we've written here, and I've replaced it with pi times d, and I'm just going to prove really quickly 1/2 times 3.14 times 8 plus 12 plus 1/2 times 3.14 times 8 plus 12. Alright, so when I do all this multiplication, this gives me 4 times 3.14, which is going to give me 12.56 plus 12 plus 12.56 plus 12. Combining these two gives me 24.56. Plus these two is also 24.56, which gives me 49.12. So we can see that it gives us the same answer once again, and we prove that algebraically over here by combining like terms, and it kind of simplified our work for us. So this is part of the importance of being able to write an expression and then be able to simplify that expression. Alright, so coming over here, we've got one last problem. It tells us Mary and Margaret are looking at a map of a running path. The shorter path, we're trying to figure out which path is shorter here, whether it's the one large semicircle. Okay, so this is one path that they could take, is this one large semicircle, or if it's this two semicircles, they run here and they run here, which one would be the shorter distance? Okay, so when we're looking at this, we need to make sure that we have things measured out here. It tells us the diameter of the entire thing, we can see here, would be 4 kilometers. Decide between your group what would be the distance or the diameter of these two smaller semicircles. What would be the distance or diameter of these two smaller semicircles? Please make sure that you have that idea within your group. Go ahead and label it on your graph, or on your picture, on your diagram. Okay, hopefully you and your group have determined that this is half of the semicircle, so these would each have a diameter of 2 centimeters, which means they're the same. Alright, so the distance for the big semicircle. Go ahead and find the distance for the big semicircle and for the two smaller semicircles. Make sure you've paused the video until you are done with this work, as I'm going to go over it now. Alright, for the larger semicircle, this is going to be half of a circumference. So it's going to be half of a pi times d. It tells us to approximate pi with 3.14, so half of 3.14 times 4. I'm going to go ahead and put that all into my calculator, and that's going to give me 6.28 kilometers. All right, make sure you found the distance for the two small semicircles before you move on. So for my two semicircles, it's half of a circumference plus half of a circumference, which we've seen earlier. We can actually simplify this. If you didn't do it this way, go ahead and simplify it now. Tell me what that is equal to. So half of a circumference plus half of a circumference. This is actually a full circle if we put the two of them together, which is equal to pi times d. And the diameter of the two smaller semicircles is 2. Pi times d would be pi times 2. Which also gives me 6.28 if I plug in 3.14 times 2. So it asks you to fill in the blank here. The blank path is shorter by blank kilometers. Well, actually, if we start to look back at our work here, is this sentence even useful? The answer is no. The two paths are equal distances. Alright, it says suppose they decide to run the big semicircle one way and then run back using the two semicircle path. How far will they run in total? Go ahead and talk with amongst your group and determine how far they would run in total. So the large semicircle plus the two small would be 6.28 plus 6.28, which gives us a total of 12.56, and our measure here is kilometers. So 12.56 kilometers. This up here was kilometers as well. Okay, so that's our lesson for today. Please go ahead and move on to your independent work. Make sure that you're working on the alone time silently and independently. Once you've finished with that, if you look over at your alone time, you should have time to get on Khan, where you are given this particular module. This will kind of help make sure that you've reviewed your radius, diameter, and circumference. And then a bonus is the circles and arcs. And what I'm going to tell you is that when we're talking about circles and arcs, if you want to find the fraction of the arc that you're finding of, so if it tells you the arc that you're finding is x degrees, if you divide that by 360, that would be the total degrees around the circle. This is the fraction of the arc that you're trying to find. So it would be whatever that measure is divided by 360 times the circumference. That would give you the distance around that arc. Alright, so that's kind of a little bit of a bonus work. That's what you should be working on once you finish the radius, diameter, and circumference, which will be super easy. The one thing I will tell you about is in Khan, when you're giving your answers, it's not going to ask you to use 3.14. It's going to ask you to leave your answer in terms of pi. So perhaps you might get the answer 12 pi as your answer. It's going to ask you to put that in as 12 pi. That's for both of these modules when you're on circumference or when you're on the circles and arcs. All right. So that's just a little bit to get you started. But go ahead and finish your alone time first, and then hop on to your Chromebooks.